Hi everyone, welcome back to Chemical Engineering Statistics. In the previous chapter, we studied about hypothesis test and confidence interval for a single population parameters, such as the mean, mu, the variance, sigma square. In this chapter, we will extend those results to the case of two independent populations. The statistical inference for two samples or two populations can be divided into two. First, when we have two independent samples, and the second is when we have two paired samples. The cases when we have two independent samples can also be divided into two. First is when we have two independent samples with known population variance and or they have large sample sizes which are n is more than 30. And the second is when we have two independent samples with unknown population variance and the sample sizes are small. The general condition for two independent sample comparisons is presented in the top left figure. We can see from the figure that population 1 has a mean of mu1 and the variance of sigma square 1. The population 2 has mean mu2 and variance sigma square 2. Inferences will be based on two random samples of size n1 and n2. x11, x12 until x1 n1 is a random sample of n1 observations from population 1. And x21, x22 until x2n2 is a random sample of n2 observation from population 2. For two independent samples, we can consider the inference on the population parameters such as mean and variance or standard deviation. So what does independent sample mean? Independent sample means they have no correlation between sample members. If we look at the right top figure, we can see two groups of vegetables. On the left, we can see the group of vegetables which was grown without biochar. While on the right, we can look at a group of vegetables which were grown with the help of 40% of biochar. Those vegetables were grown from different seeds, so they are independent samples. They don't have correlation between each sample members. The hypothesis test of mean of two independent samples with non-population variance and or large sample sizes can be conducted following this scenario. So, as usual, first we have to determine what is the null hypothesis. Remember, the null hypothesis always contain equality. So here we can see that the null hypothesis H null is mu1 minus mu2 equal to delta 0. Delta 0, of course, has a predetermined value. Usually it is 0. And the test statistics is Z0 as shown in this slide. For the alternative hypothesis, depend on the case, we can choose between three options. The first one, mu1 minus mu2 is not equal to delta 0. The second, mu1 minus mu2 is more than delta 0. And the third is mu1 minus mu2 is less than delta 0. The rejection criteria for the fixed level test will follow the alternative hypothesis that was chosen before. It will be good if you can try to do this exercise. So in this exercise, we have a product developer of paint. So he wants to reduce the drying time of a primer paint. He tried two formulations of the paint. The formulation 1 is the standard chemistry, and the formulation 2 has a new drying ingredients. From the experience, it is known that the standard deviation of drying time is 8 minutes. He chose 10 specimens painted with formulation 1 and 10 specimens painted with formulation 2. The two samples already has average drying times, which are 121 minutes and 112 minutes respectively. So if we look at this case, we only have 20 specimens. But remember, we already know the standard deviation of the drying time. Okay, so even though the specimen or the sample is less than 30, we know the standard deviation of the population. So in this case, we can use the z-value calculation. So to draw the conclusion, first we look at the parameter of interest. Here, the parameter of interest is the difference in the mean drying times, mu1 minus mu2. For this case, we choose delta 0 value as 0. The null hypothesis is mu1 minus mu2 equal to 0. The alternative hypothesis that we choose for this case is mu1 is more than mu2. So in this case, we want to reject the null hypothesis if the new ingredients reduce the mean of drying time. Then using the available data, we can calculate the test statistics Z0. Okay, so after do the calculation, we can see that we reject the null hypothesis because the p-value for this test is 0.0059, which is much more less than 0.05. So that's all for today. See you on the next video.